One of the most relevant areas of science explored in Antarctica is its studies of space weather. While it might sound cool, this form of weather actually has the potential to be not only beautiful, but deadly. Solar radiation interacts with the highest part of the Earth's atmosphere to cause space weather, most of which occurs within the interaction between the Sun and the Earth's magnetic field and atmosphere. Let's begin with a type of space weather we all know and love, the Southern Lights, or the aurora australis. The aurora takes place in the ionosphere of the Earth's atmosphere, which is 85 to 1,000 kilometers above sea level, caused by the charged particles from space interacting with the magnetic poles. Where does the ionosphere come from? When extreme ultraviolet radiation strips the electrons from and charges gases in the upper atmosphere, this layer is created. The highest concentrations of these charged gases can be found at the poles, resulting in the aurora. When disturbances on the Sun release charged particles, they react with the charged gases in the upper atmosphere near the poles and create a neon glow. It gets its many different colors from the principle that particles with different energies ionize different gases. While aurora is completely harmless and stunning, other types of space weather don't just affect the atmosphere but the everyday lives of people. Geomagnetic storms, like solar storms, are very large threats to human society, with the potential to disrupt power grids, communication satellites, and other technology. Just one serious event could cost $1.3 trillion a year. Solar weather is made up of protons and electrons ejected from the sun's surface at speeds of hundreds of kilometers per second. As it hits Earth, solar wind manipulates the shape of the magnetic field and affects the currents flowing around the planet. Satellites are the most prevalent victims of this dangerous form of space weather. Charged particles penetrate them and disrupt sensitive electronic components, causing many failures in their systems and reduced lifespans. Solar flares that are directed toward Earth increase drag on satellites, hurting the transmission of radio frequencies. As an example, the GPS will encounter errors in the event of a solar flare. Intense solar winds can also damage solar power arrays. Another potentially dangerous form of space weather is the coronal mass ejection. When the sun sends off concentrated bursts of solar wind, the amount of energy equal to multiple atomic bonds is sent rushing toward the Earth. If our planet is hit by one of these, the magnetic field is distorted, resulting in major power system failures. For example, on March 3, 1989, there was a major blackout in Quebec, Canada, as the result of a coronal mass ejection. 6 million people lost power for 9 hours. According to the UK National Risk Register, space weather is one of the highest priority national hazards. Additionally, electricity failure is ranked third behind pandemic influenza and coastal flooding, something that will also pose a problem should we fail to protect the Antarctic. As stated by the Register, while storm impacts in the mid to late 20th century were relatively moderate, dependency upon technology vulnerable to space weather has pervaded many aspects of modern life, and therefore the disruptive consequences of a severe solar storm could be significant. Should space weather pose a threat to Earth, power networks will fail and be interrupted, causing damage to a wide variety of equipment. Meanwhile, satellites and GPS systems will be interrupted, as well as aviation, essentially messing with the controls on aircraft. In fact, all modern technology will be disrupted. Recovery from a massive loss of electricity could take up to 5 days, hurting the economy and millions of consumers. It could even take weeks to restore power. Lastly, there will be a negative impact on public health because of higher radiation, with additional casualties and fatalities due to loss of electricity. So, what is being done to lessen these effects and prevent this? Work is already being put toward finding a better understanding of space weather and how to plan for it. The Department of Energy and Climate Change is working with the National Grid to better prepare for impacts. Meanwhile, scientific and engineering experts are gathering together to discuss their findings and impacts on the infrastructure. Various organizations are also giving space weather forecasts and working to build resilience. Because space weather's consequences can be felt globally, countries are working together to exchange information. We know that space weather is potentially very dangerous and that we are working to prevent the damage it can cause, but how does Antarctica help any more than the rest of the world? Well, Antarctica's extremely dry and cold air makes it ideal for cosmic, seismic, and atmospheric observations. As we work to understand how the sun and space influence the Earth, Antarctic research contributes to data used to inform centers, surveys, and councils around the world dedicated to this cause. Space weather is being researched at 5 different locations in Antarctica. Because of the optimal conditions, these observatories are crucial to solar weather studies. When we work to conserve Antarctica, we are not only protecting distant climates and animals, we are protecting ourselves. The continent is extraordinarily valuable to the scientific community, and many of its stations are irreplaceable. Space weather poses a very dangerous and very real threat to the modern world, and it is imperative that we take action to support scientific research down on the ice. After all, we won't be able to predict when it will come in handy.